Hey, are you ready for a new week? Are you ready for some new information? Then this is the video for you. In this episode, we're going to be talking about homeostasis. We're going to get back into our survival journal, and we're going to be talking about genetics. So we don't want to waste any of your time. So let's get right to it. As you can see here on our screen, we've got three main topics this week. We're going to be talking about homeostasis and the body's ability to adjust to various stimulus. We're going to get back into our survival journal, as I said, in a couple of modules, and we're going to be talking about genetics. Genetics is going to be super important for us because that topic will be carried all through the month of February in some form, in some fashion, in a particular type of activity or assignment. You'll be discussing those topics. As you can see, we got 3 work days this week, Monday, Wednesday, and Friday, so a nice full week. 10 modules to get through, and so that would come out to roughly 3 point something per day, but actually on Friday, I believe there's 5. All the genetic stuff comes in at one time, so that kind of skewers the Monday and Wednesday data set. So let's get into that first topic. Topic 1, homeostasis. This topic is so important for your overall body functions, and it can't be defined as kind of one thing because it has a lot of variation and a lot of varieties based on the situation you can find it into. It can get into, as simple as altering your body temperature to other, deeper situations, like maybe you're in pain for some reason and your body's trying to adjust to that. But let's look at the idea of homeostasis kind of through some real life kind of metaphorical examples. And you can see I've got an airplane down here. If you can imagine being the pilot of that airplane, and you're flying along, and maybe in some portion of your flight, you've got a pretty strong tailwind. It's going with you, and it's helping to push you, but you have to make some adjustments to the wings and the flaps, and I'm pretending like I know pilot lingo. But you would have to make some adjustments to the plane so it flies as efficiently as possible. Now imagine that in another part of your flight, you got a nice long flight, that you're getting a slight wind coming towards you, towards the nose, against the plane. So you would also have to make adjustments to the plane to make sure it flies as efficiently as possible, as you would have to if you got a wind from the left side or the right side of the plane. You would again have to make adjustments to the plane in order for it to be able to fly as efficiently and safely as possible. That's the idea of homeostasis within your body structure and how it adapts to things. It just simply takes a stimulus and does what it can to make the necessary adjustment to reduce the impact or reduce the effect of that particular stimulus. Now it does so in a combination of ways. Again, as I mentioned, there's not one way that you could define homeostasis as a process, because it is simply it just takes all the variables, all the stimulus, and then makes whatever adjustments is needed. And it does that in a variety of ways. And I got the word negative feedback right here for you. A negative feedback pathway is resigned to do what it can to reduce the stimulus. So a couple of good examples of that is, I got a blood pressure cuff here. So let's think about your blood pressure. Say it's too low. Okay, it's lower than what your body wants it to be. So through a process of evaluation with your nervous system and decisions, and then maybe even if the endocrine system has to be involved in making adjustments. But if your blood pressure is too low and your body senses that, one of the things it could do is to reduce the diameter of your blood veins, of your veins. And by doing so, when you reduce the volume of that cylinder, the tube, your veins, you can increase the pressure. Just like if you had your water pipes at home, if your water pressure was too low, one of the things that someone could do is to decrease the pipes that you're using. And that would increase the water pressure, just like it would your blood pressure in your veins. And the opposite is also true if your blood pressure is too high. Now, if you go to the doctor and he or she says, "Oh, your blood pressure is too high," we can give you some medication for that, because your doctor isn't going to go in and replace all your blood veins. I mean, they certainly probably could do that, but that would be a tremendous overexertion of use of surgery, and I imagine very expensive as well. But what your body can do is say, okay, we're sensing the blood pressure is a little high, so what we're going to do is just increase the diameter of the veins and associated arteries and stuff, and therefore reduce the blood pressure. Another way you can think of as negative feedback is the same way your thermostat, and I got me a thermostat right here, and we're all pretty familiar with thermostats. If the house feels too warm, you simply if it's a thermostat that's just auto hot or cold, whatever if you increase or decrease, it makes that adjustment. But anyway, say if the house is too warm and you flip it over to the AC, the air conditioning, and you bump that number down, then when the thermostat receives that information, then it fires on and clicks on and runs the air conditioner, and vice versa. If it's winter time and you think the house is too cold and you've got it on heat, and you can bump that number up, and the thermostat will receive that information and will fire up, and when it gets to that proper number, then it shuts down. Okay, that's negative feedback, looking to reduce the stimulus. In this case, the stimulus maybe is the house is too cold or the house is too warm, so we're going to modify that. We're going to adjust that. Now, the other side of the homeostasis pathways is positive feedback that you can see that I have right here. Now, positive feedback is when you have a stimulus that needs to be really addressed. Say, for example, pain. Okay, you've got a pain, and although we know that we can take ibuprofen or acetaminophen or some whatever, or if it's a really bad situation, then properly prescribe something for a short period of time to help ease that pain. But your body also tries to do some things to alleviate the pain, because the body sees it as, okay, that pain is there for a reason. So while we want to monitor that, we also need to try to fix the situation that's causing the pain. And it will do so to some degree. Now, obviously, it can't short-term, fix bones or things that are really out of alignment or whack or in a bad situation. But say, for example, like you have a pain, your body can send out signals to address the situation in some degree, and as long as that pain is being felt, then the body will continue to try to remedy it in whatever way that it has determined is the best way. And then when you no longer have that pain, then that process shuts down. So it is addressing the situation, and you may be thinking, well, how are these different? The main difference between the two is the negative feedback is a constant to and fro, trying to adjust to the situation, whereas the positive feedback, once the stimulus goes away, then the remedy goes away. You can also think of positive feedback. For example, you get a paper cut, maybe there's a little bit of bleeding, or maybe you just puncture yourself, or in our case around here, you may be playing with a dog, and the dog doesn't purposely bite you, but you get a little, maybe break the skin just through playing. Maybe you just caught a tooth or something, or you're playing tug of war and they lunged at you and you didn't get out of the way quick enough. Something innocent. But you may break the skin. There's a little bit of blood flow. Your body goes right to work creating those blood clots and everything. And then once that stimulus goes away and the blood clot or the repair process is no longer needed, then it stops happening. So that's the idea of homeostasis. So now let's look at our next topic. All right, topic 2, our survival journal. As you can see here, I've got you at mod 1.24. You're going to take a look at some natural resources, some ways in which it's a couple of videos that will identify information and share information with you on these topics. And then, of course, you'll have a little bit of assignment to do with that, a little activity. And then on module 1.25, you actually get back into your survival journal, and post your next steps in that. And these two assignments are really big point-wise. They're our largest two up to this point. I think the largest we've had so far has been a 30. Maybe an earlier survival journal was a 50, and I'm forgetting that. But these two both are worth 50 points. So super important that you take care of those and do those in the manner at which the instructions are implying to you. Okay, that's topic 2. Now let's look at our next topic. All right, this topic we're certainly going to spend some time with because, as I mentioned in the intro and earlier, this topic will go through the entire month of February in some fashion. Maybe not every day, but as you look at each week of the calendar, you can see the word genetics as far as upcoming activities and assignments. And I just wanted to take this time to kind of just go over some of the basics and then transition into how you will see it this week as far as the topic of genetics. In our first teaching, just drop my word there. I'll just go with graphic here. I've got your basic setup of a Punnett square, and hopefully you're familiar with these, but if not, this is a diagram that shows the father's genotype is up here, and the mother's genotype is on the side over here. And we're talking genotype here, and if you're not familiar with that term, it's simply the use of letters to try to describe what is on the genes for a particular trait. So in this case, it doesn't identify the trait, but say we could be doing hair color, eye color, any particular trait. In this case, the use of B is typically done with color to emphasize color. So we'll just imagine we're doing hair, or you could also imagine we're doing eyes. It works out the same either way. But say we're doing hair color, and if we would have, and we can understand that brown is the dominant hair color. In other words, on the genes, that is the color that is expressed most often for people to have. So that is the dominant, the word dominant here, letter, and so it's uppercase. So you can see here that the father has a big B. He also has a little b. That means he's heterozygous, meaning the letters are different. They're not the same case size. Okay, they're the same letter, B, but not the same case size as in uppercase or lowercase. The mother, on the other hand, is two small b's. Okay, she is homozygous, meaning the letters are the same size, same case. So she would be homozygous recessive, because the lowercase letters are the recessive trait, or the trait that's not the dominant one. In this case, you can imagine that maybe that would be black hair. Okay, or in this case, you could probably look at it in three ways. That if you have both uppercase letters, No, I'm getting ahead of myself. I'm getting too technical here. Let's just back up. We're just going to deal with two colors, brown and blonde. Okay, so if the uppercase letter, the big B, would represent brown hair, and the lowercase letter, the small b, would represent the opportunity to have blonde. I say opportunity because to get the recessive trait to be shown, in other words, what you can see, or your phenotype, you have to have both lowercase letters. So if you know a person and their hair is naturally blonde, then what that means is they, on their genotype, have two small letters. In other words, they're homozygous recessive. If a person has brown hair, they could be homozygous dominant. In other words, they have both uppercase letters, but they could also be heterozygous, having a big B and a little b, because if you have the uppercase letter, then that's the trait that you're going to get, regardless if you're homozygous dominant or you're heterozygous. So again, if you're homozygous, both letters are the same case size or the same size. And if you're heterozygous, then you have one of each size of the particular letter that the trait that you're identifying. So if we looked at this genotype, this Punnett square on the left, Punnett squares are simply just a kind of a mathematical way of looking at the probability of what trait you may have. And you could look at each individual trait. But the problem with that is in a real world application, if you're thinking about even a human offspring, is that each individual trait is going to could have several genes that determine the final outcome. And you could have one gene that just simply determines, like if we're talking hair, the color. But you could have another gene that could determine the texture. Okay, you could have another gene that determined the depth of the color. Is it a dark brown? Is it a dark blonde? Or is it a light brown or a light blonde or somewhere in between? So you could have a variety of genes that all contribute to the final outcome to this, and they could modify the color. If it's a heavily textured hair or a very thick hair, maybe it comes across as being darker simply because there's more surface area, as opposed to a thinner, more wavy, or just a fine hair could look lighter because it simply has less surface area. There's a lot of variations to that. So I just say all that to just say that it's not as cut and dried as simply, do I have brown, do I have blonde, final outcome. But if we looked at these four boxes, again, this is just a probability. It doesn't mean that if a person has 4 kids, that they're going to have 2 with brown hair and 2 with blonde hair. What that simply means is that on each individual offspring, in this case, they have a 50% chance of having brown hair and a 50% chance of having blonde hair. That's the ratio. Okay, that's the phenotype ratio, and the genotype ratio would be 50 to 50, or you could reduce down to 1 to 1. In other words, you got a 50% chance of having brown hair and 50% chance of having blonde hair on each individual offspring. And again, that's well and good, but again, it doesn't mean that if they have 4 children, they're going to have 2 and 2. Each individual birth process or offspring has that 50% chance. So theoretically, you could have 4 children, and they all could be brown hair, they all could be blonde, or some combination in between. And that's for one trait. In the Punnett square on the right over here, it looks at 2 traits. Not only does it look at color, it also looks at texture, whether it's wrinkly or whether it's round or smooth. So it's also ways of looking at that. And that's a more realistic way, because as looking as a human offspring, you could just look at a particular trait if you were looking for a disorder of some kind. And that leads us into our topics this week of how we're going to see genetics being these. You're going to look at genetic disorders and how they come about and the process. But the whole idea of genotypes, phenotypes, homozygous, heterozygous, dominant, recessive, the ratio, the letter combinations, those are all going to come into play. And so we're doing this now to kind of give you some ammunition, some tools in your toolbox to help you understand what the person is talking about. So hopefully you have some experience with this, and this was a review. But if not, hopefully this helped you to fully understand. And if you'd like more on this, you have a couple of options. You can always send me a message saying, hey, can I have more? Can we talk? Can we set up a meeting? Can we discuss this idea of genetics even more? Or if you want to do it more in a relaxed setting, in a less informal way, you could certainly always pull up YouTube videos. So there's only be 1 million of them on the introduction to genetics. And so either way, you choose the way that would best serve your interest, and we will take that and go from there. Well, that's our show for this week. So hopefully that helped. Hopefully that gives you the information that you need. I look forward to seeing your progress this week. You guys are doing a great job. I mean, getting your stuff turned in, which I appreciate. I enjoy seeing your submitted work, your writings, your answers, your responses to everything. And hopefully the feedback that I provide, it's not meant to be super in-depth as far as, boy, it's not like I'm grading your paper through the feedback. But I do try to always say, hey, great job, this was good, that was good. And if something is needed to be picked up, maybe improved on a little bit, let you know that as well. So, but again, thank you for everything you guys are doing. Hopefully your week is going well, and everything is good in your world. Your family's good, you're good. And as we turn the calendar into February, that means that our class is half over. So hopefully you're on pace. If you need to do a little extra to get caught up, especially if you're newer to the class, do what you got to do, but always rely on me if you need help. If you need me, shoot me a canvas, some kind of message, something. Let's talk, let's get together, whatever we got to do to make it easier and smoother on you. So with that, hey, until next time, man, thank you. It's great being with you guys. I appreciate being a part of the educational journey, and we will see you on Wednesday.